Okay, so today we're doing 3.2 arc length and area of a sector. So we'll start with arc length. Okay, so the arc length is the piece of the circumference that's cut out by the central angle. Okay, so this bold black line here, this is your arc length. Okay, R is the radius of the circle, and theta is your central angle. Okay, so we have a formula to find arc length. So the arc length equals the radius times our central angle. Okay, R times theta. Now in order to use this formula, our theta has to be in radians. Okay, if it's not in radians, you want to convert that angle before you do your problem. Okay, so find the length of the intercepted arc in each circle with the given central angle measurement and radius. So my theta here is degrees. So I want to first convert that. So we're going to multiply by pi over 180. Okay, so that central angle in radians is actually pi over 3. Okay, so now I can find my arc length. I'm going to do 5 times pi over 3 now, which is my central angle. Okay, so my arc length is 5 pi over 3, and I am going to ask that you use units, so inches. Okay, so this example already has theta as a radian. Okay, so S equals 2 times pi over 2. These cross cancel. So the arc length is pi feet. All right, example 3 now, you're being given the arc length. Okay, so we know that we're going to have to use our arc length formula. Okay, but now instead of solving for S, we're plugging 4 in for that value. Okay, they're not giving us a radius, but they are giving us a theta, already measured in radians. Okay, so we can plug that in. Right, so in order to solve this, we would divide by pi over 9, and dividing by that is the same thing as multiplying by its reciprocal. Okay, so you could imagine this as 4 over 1, multiply across the top and across the bottom. So 36 over pi centimeters is our radius. Okay, so now same idea again, you're being given the arc length, okay, and if R represents the radius, then that means we are looking for our central angle. Okay, so 9 pi equals 3 times theta. Okay, so divide by 3. So 3 pi equals theta. This is going to be 3 pi radians, okay, because we remember using our formula, theta is measured in radians. Okay, so now pay attention to what you're being asked for. It says find the area of a circle. So area of a circle, we have to pull from prior knowledge and know that our formula for that is pi r squared. Okay, so the first thing that we have to do is look at the information that we're given. So they're giving us arc length. So the first thing we have to do is use S equals R times theta, okay, because we have to fit in the given information. So I need to say that 10 equals R times pi over 4. Okay, again, dividing by that value is really multiplying by its reciprocal. Okay, so my radius is 40 over pi inches. Okay, but that's not what the question was asking for. It was asking for the area of the circle. So we now need to take our radius and we're going to plug it into the area of a circle formula. So area equals pi times r squared. Okay, in order to square that fraction, we're going to square the top number, and then we're going to write pi squared on the bottom. So always leave it in terms of pi unless otherwise directed. Okay, so now I can cross cancel this pi with 1 on the bottom, leaving me with 1,600 over pi, and this should be inches squared. Okay. Find the perimeter of a 60-degree slice of a large pizza. Okay, and they're telling me that this has a 7-inch radius. So I'm going to draw a picture. Okay, so here's my piece of pizza. It's 60 degrees, and my radius is 7 inches. Okay, now they're saying find the perimeter. Okay, well the perimeter to this piece of pizza would be adding up all of the sides. So if I know this radius is 7, that means this radius also has to be 7. And now I just need this missing piece over here. Okay, well that represents the arc length. So the first thing I'm going to do is find my arc length for that piece of pizza. Okay, so S equals, I have a radius of 7, and now my theta, oh, well my theta is written as a degree. So I'm quickly going to convert to a radian, okay, which is pi over 3. Okay, so my arc length is 7 pi over 3. Now in order to find the perimeter, I have to add up all of these sides. So 7 plus 7 plus 7 pi over 3, okay, is 14 plus 7 pi over 3, okay, because these are not like terms. Now if you use an approximation for pi here, okay, we get approximately 21.3 inches for our perimeter. Okay, moving on to our second concept, area of a sector. Okay, so the formula for our area of a sector is written using A sub S, okay, and it's 1/2 times the radius squared times theta. And again, theta has to be given in a radian. If it's not, we're going to convert. Okay, so find the area of the sector given the radius and the angle measure. Okay, well again, this is a degree. Let me convert that to a radian. So A sub S equals 1/2 5 squared times pi over 3. Okay, so 1/2 times 25 times pi over 3. Okay, so we're going to multiply all across the top and all across the bottom. So I'm going to turn 25 into a fraction. So 1 times 25 times pi over 2 times 1 times 3. Okay, so the area of my sector is 25 pi over 6 inches squared. Okay, so again, find the area of the sector, and my theta is already given to me in radians, so that saves me a step. So my radius, nope, I'm sorry, we're doing area. So A sub s equals 1/2 2 squared times pi over 2. Okay, so 4 times 1 times pi, 2 times 2, whoops, 4. Okay, and then I can reduce. So I have pi feet squared as my area for the sector. Okay, so now working backwards a little bit, you're being asked to find the radius given the area and the central angle. Okay, so using our formula, so we now have 2 pi given to us as the value of our A sub s. Okay, so I first want to multiply on the right side. So 1/2 times pi over 9 is pi over 18. Okay, and we're going to divide by pi over 18. So r squared is 2 pi times 18 over pi. Okay, so I can cancel my pi's. R squared equals 2 times 18, which is 36. Okay, and we have to take the square root. So typically when we square root, we need a plus or minus, but since this is representing a radius, which is a measurement or a length, we are only using the positive. So my radius is 6 centimeters. All right, so some more working backwards. Find the central angle. Okay, we're being given r, and we're looking for theta. Okay, so again, I want to simplify what's on the right side. So 1/2 times 8 squared would be 1/2 times 64. So I have 32 theta. Okay, divide by 32. So this is really 16 pi over 3 times that reciprocal. Okay, so I can do some cross canceling. So 16 and 32. And now I can multiply. So pi over 6 radians. Okay, we have one more example. It's a little cut off here. All right, so find the area of a circle. Okay, so again, area of a circle. Pi r squared. Okay, so A sub s is representing the area of a sector. So I know I'm going to have to use that formula first. Okay, so 20 equals r squared times pi over 8. Okay, dividing by pi over 8, r squared equals 20 times 8 over pi, okay, which is 160 over pi. Now, notice I'm not going to square root this. I'm going to leave it as r squared because ultimately I'm trying to find the area of a circle which has r squared in the formula. So why square root something, have it look messy, and then have to plug it back into another equation and square it back anyway? Okay, so I get pi times 160 over pi. Okay, so I can cross cancel those. So the area of my circle is 160 feet squared. Okay, the very last thing that I want to remind you of that you may need is the circumference. Okay, the circumference of a circle is 2 pi r, or pi times diameter. Okay, you might need that for some of your other examples.